Very good morning. Welcome to VKP Online Tutorials. Today, we will discuss about traveling salesman problem. So this traveling salesman problem is also known as routing problem. Now let us see what is a traveling salesman problem and how to find the optimum route based on traveling salesman problem. Let us take there are three places. Let us take this is location A. I'll take this is my location A, and this is location B, and let us take location C. There are three locations. Now a traveling salesman has to visit various cities. Say in this example we have three cities. City A, say this is city A, this will be the city B, and this will be the city C. And this is the origin. City A will be the origin for a traveling salesman. Now he has to visit the different cities in order to minimize his traveling cost. So those problems are known as traveling salesman problem. For example, in this case, a traveling salesman has to visit from A to B, then B to C. Then again, he will come back to its original position, that is in home position. So that is city A. Or another option is a traveling salesman has to visit from A to C, then C to B, then again B to A. Again, he will reach his origin or his home position. So these problems are known as traveling salesman problem. So in traveling salesman problem, the person should not reach the same destination twice or thrice. So for example, say in this case we have the number of possible routes. So in this case we have number of possible routes. We have since there are three cities, therefore number of possible routes are 2 into 1, which is equals to 2. There are two possible routes. One is, what are those possible routes here? The one is A, then B, you will visit to B, then you will visit to C. This is one possible route. Then second possible route is A will be the start point, then you will visit to C, then you will visit to B, then again you will come back to its initial position, that is A. This is another possible route. So in this possible route, see here again you need to come back its initial position, that is start point, origin. So these two are possible routes. Similarly, if you suppose if you have a number of cities, or let us take 4. If number of cities are 4, let us take those cities are A comma B comma C. Say A is one city, and B is another city, and C will be another city, and D will be the another city. So these are all four different cities. A traveling salesman has to visit each and every cities in order to minimize his traveling cost. So that is traveling salesman problem. So in this case, the possible routes are possible route. Since the cities are 4, the possible routes are 4 minus 1, that is 3. So that is 3 into 2 into 1, which is equals to 6. There are 6 possible routes you will find when there are 4 number of cities. So dear friends, it is one of the important gate examination question. So if the number of cities are 5, so what will be the possible routes in traveling salesman problem? So it is an expected question. Say I will take an important gate examination problem. If the number of routes number of routes are 5, what will be the possible routes in for a traveling salesman traveling salesman problem. In a traveling salesman problem. So in this case, there are number of routes, or not number of routes, it's a number of places. Number of places are 5. What will be the possible routes in traveling salesman problem? The answer is it is 5 minus 1, that is 4. So that is a 4 into 3 into 2 into 1. So this will be the number of possible routes. Say this become 24. 24 will be the possible routes in a for this case. Number of places are 5. So, like that, you can expect 1 marks gate examination problem in a traveling salesman problem. Okay, friends. Next class, in the next video, I will explain how to find the optimum route in traveling salesman problem. So before that, we should know what will be the formulation of a traveling salesman problem. Let us see what will be the formulation of traveling salesman problem. Traveling salesman problem. See, generally a traveling salesman problem, it consists of an origin and a destination. Let us take this is my origin. Say O1 will be the origin 1. Say this is O1, and we have O2, then O3. Similarly, you have OM. You have OM. So these are the origin and destination. I will call it as let us take D1, D2, and let us take some D3 up to some Dn will be the destination, or Dm will be the destination. See, a traveling salesman, suppose if say his origin is O1, if wants to go to D1, so he has to spend some money. So that is cost C1. I am taking C11 will be the cost. He is spending C11 rupee to reach D1 from O1. Similarly, so this will be the C12. C12 indicates if a traveling salesman wants to visit from O1